All right. This is a how-to video on how to solve square root problems when you have a variable expression. Now for you today, this should be a review of what we did back in February. And so since it is a review and it is now late April, I will go back a little bit and revisit the things that we talked about in February, okay? So for our first question, we have the square root of 400 z to the 6th. Now this is actually a pretty simple problem because 400 is a perfect square and z to the 6th is the perfect square. So this is the simplest this type of problem can get. Now you will remember that we can break apart square roots in this manner. We can say this is equal to the square root of 400 times the square root of z to the 6th. Because square root of 400 times the square root of z to the 6th is the square root of 400 z to the 6th. No big deal. So now, what times itself is 400? 20. So we have 20 times, well, what times itself is equal to z to the 6th? Yeah, you're right, z to the 3rd. Because you'll remember that when you're multiplying things with the same base, so if you have a to the x times a to the y, you're going to end up with a to the x plus y power. And so the square root of z to the 6th is z to the 3rd, because z to the 3rd times z to the 3rd is z to the 6th. So the answer to the square root of 400 z to the 6th is simply 20 z to the 3rd. Moving on to the next problem, we have plus or minus the square root of 162 y to the 12th. Now, this is slightly more difficult, excuse me, because 162 is not a perfect square. However, y to the 12th is. We'll start the same way we started the previous problem. The square root of, and by the way, we're going to deal with this at the end. The square root of 162 y to the 12th can be broken apart into two pieces. So you have the square root of 162 times the square root of y to the 12th. Now let's deal with the easy part. What times itself is y to the 12th? Y to the 6th. So the square root of y to the 12th is simply y to the 6th. I'm going to write this over here. Y to the 6th. Is there a number that goes into 162 that is a perfect square? So does 162 have a perfect square factor? Well, let's go through our perfect square numbers. 1 is a perfect square, but that doesn't get us anywhere. 4 is a perfect square. Does 4 go into 162? No, it doesn't, because 4 does not go into 62. Does our next perfect square factor is 9. Does 9 go into 162?
No.
No?
Yes.
Yes? Maybe we should try it before we throw it out there, because I notice 162, when I add 162, I get something that's divisible by 3, right? I get 9, in fact. Does 9 go into 162?
Yes.
Yes. So there's a shorter way to do this, but we'll go here. So we have the square root of 9 times the square root of 18, because 18 times 9 is 162. Now 18, you're going to yell at me that there's a perfect square factor that goes into 18. What is it? 9. Okay. So this can be broken apart into the square root of 9 times the square root of 2. Well, what is the square root of 9? 3. So we have 3 times, what's the square root of 9?
3.
We can't simplify the square root of 2. And then we still have this y to the 6th. So what is 3 times 3? 9. So we have 9. Now I'm going to place everything that's outside of the square roots together. So we're going to have 9 y to the 6th times the square root of 2. And this is our final answer. Except I forgot, we are going to add this at the end because we're looking for the positive and the negative square root. So the answer is plus or minus 9y to the 6th times the square root of 2. And that's it. I'm going to go on to number 5, this one right here, because it's an extension of this problem. So instead of having a perfect square variable, now we have a variable that is not a perfect square. Because what times itself is equal to n to the 9th? Well, if you're adding them together, it's n to the 4.5 times n to the 4.5. But we don't want fractional exponents. So n to the 9th is not a perfect square. So we're going to start by breaking it apart, just like we did in the first two problems, into the square root of 500 times the square root of n to the 9th. Pick a new color here. So what goes into 500 that is a perfect square? Think big, think even. 100. So the square root of 100 times the square root of 5. Now 100 is a perfect square. 5 we can't simplify, so we don't need to go any further. The square root of n to the 9th. Now this is a little tricky. We knew that z to the 6th was a perfect square. We knew that y to the 12th was a perfect square. Is there a perfect square factor for n to the 9th? Let me ask this. We knew that z to the 6th was a perfect square. So is there a way to say n to the 9th times n to the something? Oops, sorry. Oh, it really doesn't like that. Okay, so here we go. Is there a way to say n to the 6th, because we knew that was a perfect square, times n to the something is equal to n to the 9th? What would go in this blank here? 3. Okay, so we could break it apart like that. So there's a perfect square factor for 9. But I think there's a bigger perfect square factor than n to the 6th. N to the 8th is bigger, and it goes into n to the 9th. Because n to the 8th times n to the 1st is equal to n to the 9th. So I can break n to the 9th into its pieces. N to the 8th times n to the 1st. Well, what is the square root of 100? N. Oh, sorry, the square root of 100 is not n. It's 10. I'm going to look at my other perfect square factor. What is the square root of n to the 8th? 4. So it's n to the 4th. I can't simplify the square root of 5. I can't simplify the square root of n. So what is the square root of 5 times the square root of n? Square root of 5n. And that is my answer. So I've simplified it into the, and oh, I keep forgetting the plus or minus. Thank you, guys. And so I've simplified this into its simplest radical form. Now, there are two other types of problems that you will be asked to solve with variables and square roots. The first one is when you have a quadratic expression. So if I were to give you this problem, 100 plus 20n plus n squared, what would you think you're going to have to do? You're going to have to factor it. No difference here. So we're going to have to factor this expression first. So let's go through the factoring checklist. What's the first and simplest way to factor? Sarah? Greatest common monomial. Is there a number that goes into all three of those terms? Is there a letter that goes into all three of those terms? No. The second thing that we look for is a difference of squares. And you'll remember a difference of squares typically is a binomial where both terms are perfect squares and it's a difference. It's a subtraction problem. Does this expression satisfy those requirements? So that means it's not a difference of squares. A square binomial in expanded form will be a trinomial, where the c value will be a perfect square and the a value will be a perfect square. So are these values perfect squares? Oh yeah, they are. Because 10, the square root of 100 is 10, and the square root of n squared is n. So let's try this. Let's factor this to 10, same sign as the middle term, 10 plus n squared. The middle term for a perfect square binomial will be 2 times this value times this value. So 2 times 10 times n is that the middle term I have here? This is a square binomial, which is important because it's going to be tough to square root a quadratic that isn't a square binomial. So we have the square root of 10 plus n squared. Well, what is the square root of 10 plus n squared? 10 plus n. Incidentally, could I have written it like this, n plus 10? Yeah. And that's all you got to do for this one. It's really not too scary. This last problem, we'll have to go back to what you remember with square roots. I can break this apart to say the square root of 363 x to the 5th y over the square root of 3x y to the 3rd. So that's my first step. I can break it apart into that. Then let's break apart the numerator and let's break apart the denominator. So the numerator can also be written as the square root of 363 times the square root of x to the 5th times the square root of y, all over the square root of 3 times the square root of x times the square root of y to the 3rd. Here's a little hint. If you have a square root of 3 over the square root of 363, there's a good bet that 3 goes into 363. How many times does 3 go into 363? Here's silence. How many times does 3 go into 363? 121 times. Oh my goodness, 121 is a perfect square. So we have the square root of 121 times the square root. How do I break x to the 5th apart? 4 and 1. Square root of x to the 4th times the square root of x times the square root of y. All over, oh, and I forgot the square root of 3 because 3 times 121 is the 363. And that's all over the square root of 3 times the square root of x times, well, how do I break the square root of y to the 3rd? What times what is equal? 2 and 1. So I have y, square root of y times the square root of y squared. Well, what is the square root of 3 divided by the square root of 3? Anything divided by itself is 1. It cancels out. X, the square root of x divided by the square root of x. Square root of y divided by the square root of y. What is the square root of 121? So you end up with 11. What is the square root of x to the 4th? X to the 2nd. Over, what's the square root of y squared? Just y. And so there's my answer. The one thing I would like to note is y cannot be 0 because 0 cannot go in a denominator. And so that's it. So that is an example of all the types of problems on your problem sheet that have square roots and variables that you'll have to solve.